right. So this is page 35 in the green book. And hopefully at this point everybody knows what polyatomic ions look like. They essentially look like a molecule, but they have a charge. Okay, and we're just going to skip over this bit because I don't think we need to go through it. But what we have here we have a compound. And, oh, actually, if you do not yet have a sheet, I would like you to come and get one. Okay, so come grab yourself a sheet. And if you don't have a yellow periodic table yet, you'll need a yellow periodic table today as well. Okay, so there's a couple of takeaways from this particular compound here. And the first one is that all compounds are neutral. They have a net charge equal to 0. And you can see that here we have a 2+ charge on the magnesium because magnesium is in group 2. So if you're in group 2, how many valence electrons do you have? 2, which means when they form an ion, they lose 2 electrons and they become 2 positive. Okay. We also have in this compound a -1 and a -1. Now, if we take that and we add that all up, we have 2+ plus 1- plus 1-. What do we get? We get 0, which is what we should get because all compounds are neutral. By the way, what would we call this little group of ions here, an Mg and 2 NO3s? That would be a formula unit, yes. And what do you notice is around the NO3? We have brackets. If you have more than one of a particular polyatomic ion, it goes in brackets. That's a greater than. And I'm going to start abbreviating polyatomic ion as PAI because polyatomic ion is really long to write. Okay, so if we have more than one of a polyatomic ion, it must go in brackets with the number on the outside. Subscript on the outside. So what that means is that we don't just have, you know, 2 of the oxygens or 2 of the nitrogens, we have 2 of everything that's in there. So if you were to actually count it up, the 2 applies to the N, so we actually have 2 N's. The 2 applies to the O3, so we actually have 1, 2, 3, 4, 5, 6 O's in that formula. Okay. So that is an example. There we go. And now we're going to meet some of our most famous polyatomic ions. Here is ammonium is one of only two polyatomic cations. Who is the other polyatomic cation? Please refer to your pink sheet. Who is the other one? Mercury, Hg 2+. What is the name of that ion? That Hg 2+. What is its name? You can look on your pink sheet. It's named Mercury 1, which is kind of weird because the only number I see in there is a 2. There's a 2+ and then there's a 2. So how on earth is that a Mercury 1? Well, let's take a little look. I'm going to draw down below what Mercury 1 looks like. Okay. So we have Hg 2+ really looks like this. We have an Hg, which is 1+, and we have another Hg stuck to it, which is also 1+. And this is known as Mercury 1. That 1 there, that Roman numeral 1, refers to the charge on a single mercury ion. So that's Mercury 1. If I were to give you Mercury 2, that Roman numeral refers to the charge of a single mercury. And what that would look like is it would look like Hg with a 2+ charge. Mercury's just weird. Why does it come as a little pair? I don't know, because Mercury's strange. Why is Mercury the only metal that's a liquid at room temperature? I don't know, because Mercury's strange. You know what I mean? Like, it just is. You need to remember that it is strange. So if I tell you to write a formula for Mercury 1 chloride, you're going to have to remember that it's Hg 2+ and not just Hg plus 1. Okay, it's just a weird little thing. Okay, so those are our two polyatomic cations, and we could make this structure. Do you remember what this structure is called? That is a crystal lattice. And if we looked at just one little corner here that included this bit, what's that? That's a formula unit. And if we look at ammonium, it's NH4. Look on your pink sheet and tell me, what is the charge of ammonium? It is +1. What is the charge of a chloride ion? Oh, I just wrote it. Ha ha! Couldn't even stop myself. It is -1. So once again, we have the +1, which is equal and opposite to the -1. So the overall charge of the compound is 0. So when I write equal, I really mean equal and opposite, okay? It's just, I don't know how to write that in a single symbol, so, okay. So all of these guys are all positive, 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 all the ammoniums. And then all our chlorides are negative, 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 negative. Now I want you to notice something that is not present in the formula of ammonium chloride. Which of those two is correct? Oh, I'll give you another choice. Which of those three is correct? Okay. We only use brackets if we have more than one of a particular polyatomic ion. But if we go to the next page and we have ammonium oxide, remember ammonium was NH4 plus. How many ammoniums do we have? We have 2 of them. So we have NH4 plus and we have NH4 plus, which gives us a grand total of 2 positive. And what is the charge of an oxide ion? Oxygen is in group 16. So when it becomes an ion, what does it do? It gains 2 electrons, which means its charge is 2 minus. And so the overall charge then, we have the 2 plus and the 2 minus, and that equals 0. And you'll notice we have more than one ammonium, so it goes in brackets. And here we have my best attempt at showing a 2D representation of the crystal lattice. I actually went through and cut and pasted each one of these individual little ions and pasted them together so that we had 72 NH4s, 72 NH4s for every 36 O2s, which still simplifies to a 2-to-1 ratio. There are always 2 ammoniums for every 1 oxide. Okay, here is another polyatomic ion, acetate. I would like you to go find acetate on your table of ions and see if you can find another name for it as well. Can you find another name for acetate on your pink sheet? Nobody? Look down the list. Look on your pink sheet. Okay, that's okay. You can spell it for me. Ethanoate. Okay, that's how we say it. So acetate is the common name. Ethanoate is the IUPAC name, the International Union of Physicists and Chemists. So you can use either name, whichever you prefer. And in fact, sometimes you will even see the ion written sort of differently. Okay, so it could be like this, or we could have C2, because we have 2 carbons, H3, and then how many O's do we have? We have 2 O's, and the charge is -1. So that is a possible way of writing it as well. But if you look at the structure, the CH3, we got a CH3 here, yes? And then we have a COO. So writing it like that actually gives us a better idea of what the true structure is like compared with C2H3O2, okay? So which is why we often will write it as CH3COO. Here we have sodium acetate. What do you not see around the CH3COO? There's no brackets. There's also no charge. When we write a formula, there's no charges written in the formula of the compound. There's no brackets around acetate because there's only one acetate. Does our charge balance out? Sodium is in group 1. What's the charge of things in group 1? 1 positive. Acetate, CH3COO, is 1 negative, and therefore that compound is neutral. Okay. Here's some other acetate compounds. We have calcium acetate. What group is calcium in? Calcium is in group 2. Therefore, it has 2 valence electrons. So when it becomes an ion, it will lose 2 electrons and become +2. So in order to balance that out, you need 2 acetates, each with a -1 charge, right? So that we have 2 positive balanced out by the 2 negative. And we do have to put it in brackets because there is more than one acetate. Iron 3. What does that 3 tell us? Does it tell us how many irons are in the formula? No. What does it tell us? It tells us the charge of the iron ion. So Fe is 3+. Therefore, we need 3 acetates to make a total of 3- to balance out that 3+. And finally, silver is just +1. And it's never any other charge. Silver can never be any charge other than +1, so it does not need a Roman numeral. And we'll talk about the Roman numerals in just a moment. silver's only ever 1 plus, therefore no Roman numeral. Iron could be 2 plus or 3 plus. So we need the Roman numeral to tell which one it is. We need the Roman numeral to tell us which charge. So let's pop then to your periodic table. So if you've got your yellow periodic table, if you don't have your yellow periodic table, you can flip to the first page of your workbook. Okay, and here we have this lovely periodic table, and you'll notice that the new different thing about this is we have this area that has been shaded in. On my periodic table, it's shaded in red. On yours, it is shaded in dark gray. So you can call this the red zone, or you can call it the gray zone, which might be more appropriate because yours is gray. And it also includes the lanthanides and the actinides. Now, the reason I like for it to be the red zone is because red starts with R and Roman numeral starts with R. So things in the red zone or the gray zone, we do not know their charge. Therefore, we need a Roman numeral to tell us the charge. That's in contrast to group 1. Do we know the charge of the elements in group 1? Yes, we do. What is the charge of all the elements in group 1 when they are ions? They're all +1. So we know that. So you do not write a Roman numeral saying sodium 1, because as a chemist, I'd be like, why are you telling me that? I know that sodium is +1. Whereas iron could be 2 plus, or it could be 3 plus. There's actually a few others. Those are just the two most common ones. And if you say iron chloride, I'll be like, what iron chloride? Is it iron 2 chloride or is it iron 3 chloride? Because there's two different versions. So when there's more than one version, which is the ones in the red zone or the gray zone, that's when you put in a Roman numeral. When there's only one version of the ion, you do not use a Roman numeral. So all the ones in column 1 are +1. All the ones in column 2 are +2. And I like to say that this is as easy as 1, 2, 3. Because guess what the charge is of things in column 3? +3. So even though we don't know the valence electrons really for that Group 3, it's as easy as 1, 2, 3. Whoops. So you're expected to memorize those, okay, the 1, 2, 3. You'll notice that there are other areas that are not in the red zone or the gray zone, and you're expected to memorize those as well. You should know your negative ions. If we go to our halogens, halogens are in group 17, therefore they have 7 valence electrons, and therefore when they become an ion, they will do what? Gain an electron, so now they will have a -1 charge. So the halogens are -1. Oxygen is group 16. It needs 2 electrons to fill its valence shell, so it will become -2. And guess what? I remember I said it was as easy as 1, 2, 3. What's the charge of the nitrogen group? -3. And then finally, can you see another little tiny section in there that does not have shading? These ones in here, yeah? If you had to guess, and I'll give you some other ways of remembering it in a moment, but if you had to guess, and remember, it's as easy as 1, 2, 3, what would the charge of silver be? 1 plus 1. What would the charge of zinc and cadmium be? +2. Guess what? There's 2 of them, and their charge is +2. Silver, there's 1 of them, and its charge is +1. And then how about aluminum, gallium, and indium? +3. Now, those ones you could actually figure out from their valence electrons because they are in group 13. So how many valence electrons in aluminum? 3. So when it becomes an ion, it will lose 3 electrons to become +3. So you are responsible for knowing 1, 2, 3. Over here, you're responsible for knowing 3, 2, 1, or 1, 2, 3, and you're responsible for knowing 1, 2, and 3. Anything that is not in the red zone, I'll call it the gray zone, red zone, whatever you like. Do we use a Roman numeral? No. So there's no Roman numeral. Thank you. So that's how you can tell when to use a Roman numeral or not. If it's in the gray zone, yes. If it's not in the gray zone, no. Okay. Okay, now here's a couple of, we're on page 38. I would like you to look at the carbonate ion and the bicarbonate ion and tell me, what did we add to carbonate in order to get bicarbonate? We have to add a hydrogen, and not just any old hydrogen, because we started with a 2- charge and we finished with a 1- charge. What's the charge of the hydrogen that we had to add to it? It has to be hydrogen plus. And one way of naming the ion that had the hydrogen added to it, we started with carbonate, and we end up naming the one with the hydrogen carbonate. That's pretty easy, right? You take a carbonate, You add a hydrogen, what's the name of the new one? Hydrogen carbonate. The older naming system, the more like sort of common naming system, instead of writing hydrogen carbonate, we write bicarbonate. There's no good logic behind that. It's not twice as many carbonates. It just means you added an H, okay? So anytime you go from an ion and you add an H+, you can just stick a bi in front of it or a hydrogen in front of the name, and there you go. I would like you to look on your sheet of polyatomic ions and see if you can find all of your hydrogen whatsy-wooey ions. So do you see we have all of them just in here? And I want you to make sure that you read this little or here. That means choose one of the names, not both. You could take, if you had NaHCO3, we say, okay, that's sodium. Sodium is in group 1. Do we need a Roman numeral? Do things in group 1 need a Roman numeral? No. Now I want you to watch out for this. Sometimes people get carried away and they're like sodium hydrogen carbon oxide. Don't do that. Once you've got your cation, everything else is going to be a single ion that you will find on your polyatomic sheet. So the H and the C and the O all go together. Don't name each one individually, name it all together. So you go here and you look and you say, who is HCO3? It is hydrogen carbonate or bicarbonate. So this compound, we could name it sodium hydrogen carbonate, or we could name it sodium bicarbonate. So you should only ever be naming 2 ions. You should not be trying to name 3 different things. Okay, yeah. Oh yeah, you get the pink sheet for the test. Okay, so no worries on that front. You're not expected to memorize them. Okay? Every once in a while I'll get people who write sodium hydrogen carbonate bicarbonate. I think that's because instead of having or here, they used to just be separated by commas. So that's why I got rid of the commas and put ors. Choose one or the other, not both. Okay. All right, 4.2a, let's go back. Okay. So let's take a look at these compounds here. We've got a whole bunch of them written down here. We have lithium. Lithium is in column 1, so it has a +1 charge. Carbonate, you look up its charge on the pink sheet, it is 2-, and that's why we need to have 2 lithiums to give us a total 2 positive to balance out the 2 negative. Now, do we have brackets on the CO3? No, because there's just one CO3, therefore no brackets. Now barium carbonate, barium is 2+, carbonate is 2-, so the 2+ is already equal to the 2-, so we just need one of each. Okay, and again, no brackets. But if we get tin, how would we know, what does this 4 tell us about the tin? That tells us the charge. And if you've forgotten your Roman numerals, they go 1, 2, Usually people are good with 1, 2, and 3. Now, here's the trick. If you know 5, then you actually know 4 and 6, because 4 is 1 before 5, and 6 is 1 after 5. Okay, so 4 is 1 before 5, and 6 is 1 after 5. So we have a tin 4 plus. Carbonate is only 2 minus, which means that we need 2 of them to give us a total negative charge of -4, which would cancel out the +4. And because we have more than one carbonate, we need the brackets. Sometimes people have problems like knowing what the symbol is for tin, and then they have problems finding it on the periodic table. A little trick that I used to use, have you guys ever seen those, like, I don't know if they still do this, but on TV they'd have this like this tin of like something, and you'd open it up and this like snake would spring out? Have you seen that? So you have a tin and you open it, and what comes out? A snake. SN comes out of the tin. So you open the tin and SN, a snake, comes out. Okay, so that might help you remember what tin is, because I know sometimes people go looking all over for it. But don't forget, you can also look up on the back of your periodic table, there is an alphabetical list, so that can also be helpful. Okay? All right. I would like you to try and answer this, and once you've answered it, I want you to check with your partner. If SO4 2 minus is named sulfate, and don't look at your pink sheet, just see if you can figure it out. If SO4 2 minus is sulfate, what are 2 names for HSO4 minus? Yeah, next Monday is Pro D. This Friday, yes. And then next week is the long blocks. So I think I'm going to try and get us to do at least 1 lab next week, if not 2. Okay? Huh? That's right. Yeah. Okay, so what would we name HSO4? It would be named either hydrogen sulfate, and by the way, this pH, if you prefer, you can make it an F, because that's actually the more correct version. It's just that all my resources going back like 20 years all have pHs in them, and it's too much work to go through and change them all. So, but if you want to write it with an F, that's fine. The other way you could write it is bisulfate. Plus, I don't know how to make my brain stop doing pH, so you'll just have to wait for me to retire. Okay? All right, and if we have S2 minus is sulfide, what is the name of HS minus? Hydrogen sulfide, or bisulfide. Now, do you need to know this pattern? No, because you get your pink sheet. Is it kind of nice to see these patterns? Does it make it easier for you to just bring these compounds to your mind? Yes, it does, which is why I bother teaching it, okay? All right, here we have a bigger family. We have chlorate and we have chlorite. And actually, go look at your periodic table, or not your, look at your pink sheet, and tell me, what do all the polyatomic ions, almost all polyatomic ions, end in? What are the endings of the names? 8 or 8? There's a couple of I's, yes? Ooh, by the way, every font that I will give you during any of the naming and formula stuff, your I's will always have crossbars, okay? And I think there's maybe one person in this block and one person in my other block who actually on the Lewis structure, I'm going to give you another chance to do it, because there was the, which one was it? It was CH3CL, and a couple people thought it was CI, and that made for a very complicated thing. Okay, it's not CI, it's CL. I should, but the fonts that I give you in this unit will make it really obvious. Either it's an L or it's an I. You'll never see an I like that because it's confusing. Okay, so I've deliberately chosen fonts to make it obvious. So this is never going to be CI03. This is CL03. The other way you can tell, guess what? Its name is chlorate. Does that sound like it's based on carbon and iodine? Chlorate? No, it's based on chlorine, okay? So that's another way that you can tell. Now, let's take a look. Our chlorite has one less oxygen than chlorate. And in fact, let's go to our table of polyatomic ions for a moment, and let's take a look. We have chlorate and chlorite. Can you find any other 8-ite pairs that are all identical except for the 8 and the 8? Can you find any others? Nitrate and nitrite. Nitrate and nitrate. The ite has one less oxygen than the 8. Any others? We have phosphate and phosphite. Phosphate has PO4, phosphite has PO3. So the ite has one less oxygen than the 8. And again, sulfate, sulfite, the ite has one less oxygen than the 8. Do you need to memorize that? No, because you get your pink sheet, but is it sort of a nice thing to know? And if you're carrying on in chemistry in university, chemistry 12, it's nice to be able to just pull these things to mind without having to, always be looking them up. All right, let's go back here. But wait, with chlorate, there's actually more that follow another pattern. Let's take a look at this. We have chlorate, and we have chlorite, and remember the ite has one less less oxygen than the 8. That's ClO2 versus ClO3. We actually have one that's ClO4 that has one more oxygen. Now, that's because this little per at the beginning, per comes from the same root as super, okay? Per is like super. And if you think about Superman, Superman is more than a man. He can leap over tall buildings in a single bound. He's got X-ray vision, yes? So Superman is more than a man, more than. So perchlorate has one more oxygen than the 8. And then we have nothing down here, so that's just Cl with one O, and that is hypochlorite. Now, what does it mean if you're hypothermic? You have hypothermia. Your temperature is too, you guys don't know what hypothermia is? You're too cold. Your temperature is too low. If you have a hypodermic needle, it goes under the dermis, which is the term for the skin. So hypodermic, under the skin. So hypo means under or below. Or less than. And so it has one less oxygen than the ite. Now, chlorine is a halogen, and bromine is also a halogen, and iodine is also a halogen. So could you use this little chart up here to come up with the names for BrO4, BrO3, BrO2 minus, BrO minus? Do you think you could do that? Try it. See if you can do it. So we have perbromate, bromate, bromite, and hypobromite, and we follow exactly the same pattern for these ones. And sometimes the names look a little weird, but that's okay. Periodate, and then iodate, and then iodite, and then hypoiodite. If SO4 2- is sulfate, what is the name of SO3 2-? SO4 is sulfate, SO3 is sulfite. PO4 is phosphate, PO3 is phosphite. And wouldn't it be lovely if we could always say, oh, the 8 is always the 4, right? But you can see that with the chlorate, it's a 3. It just has to do with the relative number. It's not the absolute number. You can't tell the absolute number from the 8s and 9s. Okay, this is the last one I kind of want to look at today, and this is chromate and dichromate. Is dichromate 2 chromates? Is dichromate 2 chromates? Look at the structure. Look at the formula. Is it? It almost is, but not quite, because 2 chromates would be Cr2O8, 4-, and we have Cr2O7, 2-. So the answer is no. Dichromate is not 2 chromates. And I'll tell you, so often I'll have people and they'll say, okay, I need to write a formula for sodium dichromate. And I know that, and people will just be like, oh, I know. It's Na, and they'll look up chromate, CrO4, and I must have 2 of them. Is that true? No. Dichromate is not 2 chromates. So if we did need to write a formula for sodium dichromate, we would say we have Na, which has a charge of +1. We have dichromate, which is Cr2O7, 2-. And how do we know that? Because we look it up on our pink sheet. And we look and we say, I have 2- here. That means I need to have 2 pluses to balance that out, which means that now my formula would be Na2 Cr2O7. Okay? All right. Let's try naming just these 3 on the left. NaCrO4. What's the name of Na? Sodium. Does it need a Roman numeral? No. How do we know it does not need a Roman numeral? It's in group 1. It is not in the gray zone. So then we just look, and remember, you're only ever going to name 2 ions. So you've named the sodium. That means you're not going to say sodium chromium oxide. No, 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 not sodium chromium oxide, sodium, and then everything else is a group, and you look it up on the pink sheet, and you say that is sodium chromate. Al. Al is aluminum. Do I need a prefix? No, because ionic compounds that begin with metals do not use prefixes. So it's aluminum. Does it need a Roman numeral? So it is not in the gray zone. Okay, so we just have aluminum, and then we look at everything else and we name that. That is chromate. Cu is copper. Does copper need a Roman numeral? Yes. It is in the gray zone. So here is how we figure out what the Roman numeral is for copper. So I'm just going to put a bracket here, leave a space for that Roman numeral, and then I'll write chromate, and we'll figure out what Roman numeral to put in there. Sometimes you can just do this in your head, but I'm going to write it out so you can see the steps. We have 2 coppers, so I'm going to write out Cu and Cu, 2 coppers. How many chromates do we have? Do we have 1 chromate or do we have 4 chromates? We have 1 chromate. If I wanted to have 4 chromates, it would look like this. Okay, that would be 4 chromates. But this right here, that's just 1 chromate. Chromate contains 4 oxygens, so that's what you got there. So you got 1 chromate, CrO4, so we'll draw 1 chromate. And you should always be able to tell what the negative ion charge is, okay? Because where can we look? On our pink sheet. And the charge of chromate is 2 minus. That means my total negative charge is 2 minus. I need these things to equal out to 0, which means that my positive charge has to be equal and opposite. So the positive charge has to be 2 plus. But I need to take that positive charge and say it came from 2 coppers. So I need to spread that charge out onto the 2 coppers. What will the charge of each copper be? Plus 1. And this number here, this charge, okay, the Roman numeral is the charge on a single copper, not both coppers together. It's the charge on a single copper. Now, if you feel like you've got the figuring out the Roman numeral thing down, you can ignore me and start working on that, but I'm going to give a couple more examples of how to find Roman numerals. Let us name Mn3 PO4 2. Well, the first thing we're going to do is we're going to say Mn is manganese. And then we say, does it need a Roman numeral? We go to our periodic table. And we look up manganese. Manganese is in the gray zone, therefore it needs a Roman numeral. So let's go figure out the Roman numeral for manganese. I don't know why it put me all the way back to the beginning. That's crazy. But anyway. Oh, that's not the page I want anyway. Ah, okay, there we are. Okay, so we have manganese. And in order to figure out the charge, I'm going to look and I'm going to say I have 3 manganese. So I'm going to draw 1, 2, 3 manganese. I also have 2 phosphates, so that's going to be a PO4 and a PO4. So step 1 is to write out all the ions. Step 2, find the charge of the negative ion. And that's either going to be on your periodic table or it's going to be on your pink sheet. The charge of PO4, look on your pink sheet, it is 3 minus. Step number 3, find the total negative charge. So that's 3 plus 3 is negative 6. The total positive charge is equal and opposite to the total negative charge. So essentially the total positive is equal to the total negative, just with a positive sign in front of it. So that's going to be positive 6. But then we have to say, I got this positive 6 by adding 3 manganeses together. So that means that each of the manganese had to be, we split up that 6 into 3 places. So each of them had to be 2 plus. So my Roman numeral then, that little 2 plus goes right in the brackets, and the Roman numeral is a 2. We don't write 3 because the Roman numeral does not tell us that there are 3 manganese. It tells us that the charge of a single manganese is 2. And then we just name phosphate. So step 5 is spread out the positive charge, spread out the positive charge onto all the, evenly onto the cations. You don't have to show your work for this. If you can just do it in your head, that's fine. But I have left room in the worksheets for you to do this if it is helpful for you. Okay? And I will do one more example, just because I can. Why not? SnO2. Who is Sn? Do we remember? Tin, because if you open the tin, the snake comes out, right? So we have tin, and we look on our periodic table and we say, does it need a Roman numeral? Here's tin. Yes, it does. It's in the gray zone. So it does need a Roman numeral, so I'm just going to put the brackets there. And then this is just oxygen, so that is oxide. So we're going to write out all the ions. I have 1 tin and I have 2 oxides. We know that oxygen is group 16, therefore it will gain 2 electrons to become full, therefore it's going to be O minus. So each of the oxides is 2 minus. So for a total of 4 minus. Because all compounds are neutral, the total positive has to equal the total negative, which means that Sn is going to be 4 plus, and this time we don't have to spread out the charge because there's only 1 tin ion. If there had been 2 tin ions, they would both be +2. But there's only one, so it's +4. And if you remember your Roman numerals, 1, 2, 3, and then there's 5. So 1 before 5 is 4. And then 6 would be 1 after 5. Okay? So if you've not done quiz number 3, make sure you do quiz number 3 right now. You have 5 minutes or so. Should be enough time. It's a quick one. You can work on 4.1D and 4.1E until you are ready for quiz 4. And then if you have time today, you can write quiz 4. If not, it's totally fine to write it tomorrow. Okay, so you're looking at being done quiz 4 by tomorrow.
Yeah, the structure.
Yes, it's a little long.
Yeah, that's okay.
You're sure? Okay,
yeah.
Cool. Lewis quiz. There we go. There we go. Hand stuff back as well, so just pay attention for your name once I find where I put your stuff. There we go. Zenab. Hagen. That's just a reminder. Hagen. Sarah. That's just a reminder. Okay. Daniel. I thought you did the Lewis quiz, but it wasn't with all of them. The Lewis quiz. Did you do that? Because I don't have one from you. I took them all home on the weekend and I don't have one from you. So you can do that next day, okay? That's just a little reminder. It's too long to write in 5 minutes, so you can do it next day, okay? Carly's not here. Ricardo. Laura. This is just a reminder that you have not written that quiz yet. Okay, Max. And that's just a reminder of the quizzes you haven't written, okay?
Gotcha.
Okay.
Yeah, those people back up.
Yeah. Hagen. Timmons. Oh, and Timmons, you're going to redo question number 1 for me. Okay? So just do it and hand it back. Hi. Perfect. Yes. Good. Yep. Sasha. Andrew Pan. Ricardo. Ricardo. Alex. Yuri. Danica. Molly. Dayun. Yeah, thanks. Elijah. Sonia. Marina. Julia. You grabbing both? Marina's and yours? Okay. Jilly. Minnie. Ethan Koo. Lance. Bryden. Hayden. Sarah. Isaiah. Okay, never mind. Laura. There you go. I know some people might want to just redo the ionic part. That's fine. You'll just need to turn in your quiz as well, okay? Your original quiz if you want to just redo part. Thank you. Oh, perfect. Sounds good. Okay. Oh, yeah, like first period? Yeah. Yeah, yeah. Thank you. And your quiz. There you go. Thank you. How many CLs are there? You know what? You're going to run out of time. Do you want to do it next day? Yeah. That way you can take your time and not like try and rush and get it wrong. Yeah.